Hi friends, today in this session we are going to speak about the simple resistance circuits and how to solve that simple resistance circuit, how the current is flowing inside that circuit, and what are the voltages and current across the circuit center. For that, we'll start from the very basics, that is, now we are having a circuit like this. This is a circuit with a 2 ohm resistor, and let's assume we are having a 10 volt battery connected to it. And from this, what you should understand is this 10 volt battery is supplying a potential difference, that is, it's applying a potential difference on this resistor, which is causing current to flow through the resistor. And the potential difference is across these two terminals. And let me write the potential difference as, here there is a 10 volt and here there is a 0 volt. As a result, there is a potential difference of 10 volt between the 2 ohm resistor, and that will cause a flow of charge, or that will cause a current through the circuit like this, and there will be a current in this direction. In order to find out current, the basic equation that we know is I is equal to V by R. In this case it is 10 by 2, that is equal to 5 ampere. Therefore, the current flowing through the circuit is 5 ampere like this. And this is our very basic circuit. And next, if we are having a circuit like this, let's have a circuit with a 3 ohm resistor, a 2 ohm resistor which is connected in series. It is connected in series to a, let's assume that we are having a 10 volt battery connected like this. And in this case, now the potential difference applied across the two resistors in series is 10 volt. That means, is the potential difference across this 3 ohm resistor 10 volt? No. Is the potential difference across this 2 ohm resistor 10 volt? It's no. Is the potential difference across this 2 ohm resistor 10 volt? Yes. The potential difference across this 2 ohm resistor is 10 volt. But the potential difference across the combined circuit is 10 volt. That means, let me write it like this. Here there will be a 10 volt potential, and here there will be a 0 volt potential. This potential difference is 10 volt. And in order to find out the current flowing through the circuit and the potential difference across each resistor, let's find out the effective resistance. Since it is series combination, the effective resistance is R1 plus R2. That should be equal to 3 plus 2. 3 plus 2 is 5. 5 ohm is the effective resistance, and the total potential is 10 volt. That means I is equal to V by R, that is 5, 10 by 5, that is equal to 2 ampere. And now we understood there is a 2 ampere current flowing through the circuit. Through which resistor? There is no alternate way, there is only one way in which the current can flow. Therefore, whatever current which is flowing through the 3 ohm resistor, it should be equal to the current flowing through the 2 ohm resistor. In series combination, current will be same. Therefore, the current flowing through the 3 ohm resistor is 2 ampere, and the current flowing through this 2 ohm resistor is also 2 ampere. Clear? And in order to find out the potential difference across this resistor, the things that we know is resistance is 3 ohm and current is 2 ampere. From this data, if we are calculating the voltage, V is equal to IR, that is 2 into 3, that is equal to 2 3s are 6 volt. Therefore, the potential difference across this 3 ohm resistor is 6 volt. That means, if this is 10, means in order to create a potential difference of 6, this potential over here, it should be 4. Therefore, the potential difference between these two terminals will be this is 10 volt and this is 4 volt. Therefore the potential difference between these two terminals, it will be 10 minus 4, that is equal to 6 volt. Okay, then in this case, if we are calculating the values, the resistance is 2 ohm, the current flowing is 2 ampere. As a result, the potential across this 2 ohm resistor will be V is equal to IR, that is equal to 2 into 2, that is equal to 4 volt. Therefore, you can clearly see if this terminal is having a potential of 4 volt and this terminal is having a potential of 0 volt, the potential difference is 4 minus 0 is 4. Therefore, the potential difference is 4 and 6 plus 4 is equal to 10. Okay. Now, let's have a parallel circuit. In order to have a parallel circuit, let me draw a circuit like this. If this is our circuit, means let's assume that this is a 10 volt battery and let this be our 3 ohm resistor and let this be our 6 ohm resistor. And now we have to analyze in this case, and in this case also the combined potential is 10 volt. The battery is supplying a potential difference of 10 volt. That means the potential across this terminal is 10 and the potential across this terminal is 0. That means, is there any resistor over this wire? No. If there is no resistor in between, the potential over this terminal will be equal to potential over this terminal. That is, there won't be any potential difference. If this is 10 means this is also 10, and I could write this terminal is also 10. Why? There is no resistor between these two. And if this is 10 means this is also 10. And likewise, if this is 0 potential, then this terminal will also have a 0 potential, this terminal will also have a 0 potential, and this terminal will also have a 0 potential. In short, the potential difference across this 3 ohm resistor, it will be exactly 10 volt. By this terminal is having a potential of 10 and this is having a potential of 0. The potential difference is 10 minus 0, 10 volt. Therefore, from these datas, let's solve the 3 ohm resistor's case. In this 3 ohm resistor, resistance is 3 and the potential difference is 10 volt. In short, you could see in parallel combination, voltage or potential difference is same. What was in the case of series combination? In the case of series combination, current was same. In the case of parallel combination, voltage is same. Resistance is 3 ohm, voltage is 10 volt. Therefore, I is equal to V by R, that is 10 by 3 ampere. This is the current across the first 3 ohm resistor. Let me mark it as I1. Therefore, I1 is equal to, what I could write is, I could write V by R1. Why V by R1? Voltage is same. Therefore, like this. And if we are analyzing this 6 ohm resistor, we could clearly see this 6 ohm resistor, R is 6 ohm. Let me write R2, second resistor. Then voltage is 10 volt. Therefore, current is V by R, that is I2 means V by R2, that is equal to 10 by 6, that is 5 by 3 ampere. Okay. Therefore, the current will be flowing as 5 by 3 ampere. The I1 current, this is I2 current, and I1 current, it was 10 by 3 ampere. Okay, then let's find out the effective resistance. In this case, the effective resistance is, we could use the formula Rp is equal to R1 R2 divided by R1 plus R2. Actually, it is 1 by Rp is equal to 1 by R1 plus 1 by R2. If you are cross multiplying and taking the reciprocal, you will get this formula. Okay, then in this case, Rp is equal to R1 R2. 3 into 6 divided by 3 plus 6, that is 3 into 6 divided by 9, and on simplifying we'll get 2 ohm. Therefore, I could draw the equivalent circuit of that parallel combination like this. That is, we are having a 10-volt battery and the equivalent resistance is 2 ohm. And let's analyze the situation. If we are analyzing the situation, if you are looking at this single case, what's the voltage? 10. Resistance is I is equal to V by R. That means that is equal to 10 by 2, that is equal to 5 ampere. That means this current is 5 ampere. If this current is 5 ampere means what we could say, this current should be also 5 ampere. And let's analyze this. Let's call this current as I. Let's call this current as I. And on analyzing the circuit, this I current is branching into I1 and I2. Then if this is correct means let's analyze. What's the value of I1? I1 is 10 by 3 ampere. I2 is 5 by 3 ampere. And what is I1 plus I2 in this case? It is, let me write over here, 10 by 3 plus 5 by 3, that is 15 by 3, and 15 by 3, it is what? 5. Therefore, this 5 ampere is branching into 10 by 3 and 15 by 3. Now we understood about the parallel combination also. Then let's move on to the next situation. On the next situation, let's make a slightly complicated circuit. That is, let's have a resistor of 2 ohm over here, and let's have a resistor of 3 ohm over here, and a resistor of 4 ohm. Then it's connected to, assume that it is connected to a 10-volt battery like this. And analyzing the situation, let's analyze the situation. 10-volt battery is giving a potential difference across these two terminals. Clear? Therefore, this terminal, let me write, this is having a potential of 10 and it should have a potential of 0. For making it a little bit more user friendly, let's call this point as A and let's call this point as B. If this potential is A, then will this potential be A itself? No. The reason for that was there's a resistance over here. The potential over here is equal to here. That means there is no resistance in between. Therefore, if I am asking you if the potential over this terminal is B, can you say what's the potential over this terminal? Is it B or not? Yes, it is B. The reason is there is no resistance, therefore there is no potential difference across these two terminals. And the potential over here is B and the potential over here is B. Clear? Or 0. Anything. And let me call the potential over here. Let's call it as C. Okay, the potential over here is different. And next, let's find the solution of this portion. This is 3 and 4. For our mathematical simplification, let me take 3 and 6. Can you say why? We know the parallel combination of 3 and 6. We have done the mathematical simplification in the previous problem. That is, if we are solving this circuit, Rp is equal to R1 R2 divided by R1 plus R2, that is 6 into 3 divided by 6 plus 3, and from the previous derivation we know it is 2 ohm. Okay, therefore this circuit can be simplified like this. This 2 ohm is our 2 ohm over here and the effective resistance is 2 ohm, therefore 2, and it is connected to a 10-volt battery like this. And from this what is the effective resistance? What is the effective resistance? Rs is equal to 2 plus 2, that is equal to 4 ohm. What's the total potential in this case? The total potential is 10 volt. Therefore the total current I is equal to V by R, that is 10 by 4, that is 5 by 2. 5 by 2 means 2.5 ampere. And from this diagram we could say the current flowing through this circuit will be 2.5 ampere. That means the current flowing through this 2 ohm resistor, it should be 2.5 ampere, and the current flowing through this 2 ohm resistor, it should be also 2.5 ampere. Then you just focus your attention over this 2 ohm resistor. In this 2 ohm resistor, what is the resistance value? In this case, R is equal to 2 ohm. Clear? And what is the current flowing through this 2 ohm resistor? It is 2.5 ampere. Then can you find out the voltage? V is equal to IR, that is 2.5 into 2, that is equal to 5 volt. That means this case also the voltage will be 5 volt. Why? Current is 2.5 and resistance is 2, therefore 5 volt. And what is this 2 ohm resistor? It is the effective resistance of these two. And can you recall what's happening in parallel combination? In parallel combination, voltage was same, and from our previous problem the 10 volt potential was equal to the voltage across the two resistors in parallel combination. That means what I am trying to say is, if this 2 ohm is having a total voltage of 5 volt, then the voltage across this 3 ohm resistor and 6 ohm resistor is also what? 5 volt. Let me mark this point. This is our point corresponding to B, and this point C, it will be somewhere over here. It is the point corresponding to C over here, and this is the point corresponding to A. What is the potential difference between A and C? It is 5 volt. Therefore this is 10, means this should be 5 volt. 10 volt means this should be 5 volt. And what is the potential over here? It was 0, therefore this potential is also 0, therefore this is 0. Then what's the potential difference across this 2 ohm resistor? This is 5 volt. 5 volt. And what's the potential difference across this 3 ohm resistor? This is 5 volt, means this terminal should be 0 volt, and if this is 5 volt, means since there is no resistors, this potential should be equal to this potential. This 0 potential should be equal to 0 over here. The potential difference is 5 volt itself. Therefore in this case resistance is 3, voltage is 5 volt, and current will be V by R, that is 5 by 3 ampere. And in this case resistance is 6 ohm, voltage is 5, therefore current is equal to 5 by 6 ampere. Okay, then can you recall the total current? It is 2.5 ampere. And if you are adding this current, let me call it as I1, and this current as I2. What is I1 plus I2 in this case? It is 5 by 3 plus 5 by 6. I could write 10 by 6 plus 5 by 6, 5 by 6, that is 15 by 6, that is 5 by 2, that is equal to 2.5 ampere. Okay. Therefore, after solving this complete circuit, let me make some conclusions. We were having a 10-volt battery. It was connected to a 2 ohm resistor, 6 ohm resistor, 3 ohm resistor as in our circuit diagram. As a result, what happened is the 2.5 ampere current was passing, and it was passing through this 2 ohm resistor, 2.5 ampere current, and this current branched into two currents, and it was branching into 5 by 3 ampere and 5 by 6 ampere. Then the sum of 5 by 3 plus 5 by 6 is 2.5. Therefore, it is then passing as 2.5 ampere and completing the circuit. The voltage across this 2 ohm resistor, it is 5 volt. 5 volt. The voltage across this 3 ohm resistor, it is 5 volt. The voltage across this 6 ohm resistor is also 5 volt. Okay.